Let us discuss normalization in database. Normalization. In this video, let us discuss about third normal form and BCNF. As we discussed in another video, that's nothing but normalization is used to reduce the redundancy, and that is the main focus of normalization. And here we use functional dependencies. So we should know the functional dependencies. What is functional dependency? So there is a functional dependency x to y. So x is determinant, y is dependent. So x determines y. X is one attribute, y is another attribute. So we identify y attribute by using x attribute. That is functional dependency. Of course, here we have so many normal forms: first, second, third, fourth, BCNF, 4NF, 5NF, and 6NF. Most of the databases will satisfy BCNF. Very few will be in 4NF, 5NF, and 6NF. And these are very rare, but mostly we use up to BCNF. In first normal form, repeating groups should be eliminated. And we have gone through some examples. Of course, other point is only atomic values should be placed inside a column value as a column value. Atomic values means singular values but not multiple values. So two values are there. Those two should be placed in two different rows, but not at a single row in a single cell. Then second normal form. In second normal form, we have to eliminate the partial dependency. Means what? There should not be a partial dependency, or there should not be augmentation. Partial dependency means, for suppose when you look at composite primary key, some parts of, for suppose these two are primary keys. Okay, these two are primary keys, and the remaining are normal attributes. Generally, together there should be a dependency with each other attribute together, but sometimes from single also there is a possibility of dependency. Okay, so such kind of things should be eliminated. No partial dependency, it should be full. Okay, not on the subset, it should be full. Okay, so we have gone through one example, and another one is third normal form. So first normal form, atomic values. Second normal form, no partial dependency. And third normal form, first point is, first a table should be, or a relation should be in second normal form primarily. Then only we can bring that one to a third normal form. We cannot bring a relation which is not in second normal form into third normal form. Okay, of course, here we concentrate on the main point, transitive dependencies. So we will look for transitive dependency and we will remove them. Okay. Now, non-key attribute may not be functionally dependent on another non-key attribute. For suppose this is a table, and these are the columns. Okay, so column 1, column 2, column 3, column 4. Now consider this one as a PK, that's nothing but primary key attribute. This is key attribute, and all these are non-key attributes. So there should not be any dependency between one non-key attribute to another non-key attribute. For suppose this is X attribute, Y attribute, Z attribute, and some K attribute. So primary key is X. So there should be dependency between X to Y, X to Z, and X to K. That's it, but not Y to Z. Okay, so that is what this one. A non-key attribute may not be functionally dependent on another non-key attribute. Okay, so let us that is what transitive, or suppose transitive in the sense it is like this. Let us look into this. Generally, a PK determines, a key attribute determines a non-key attribute. Means what? There will be a functional dependency between X to Y. Means what? X determines Y. Now, if Y determines Z, then X determines Z. Like this, we have studied transitive dependency in functional dependency video. Okay. Now, that should be eliminated here. If a transitive dependency is like this, then it should be eliminated. Then only a table or a relation is said to be in third normal form. Okay. So in transitive dependencies, what is there? From a non-key attribute, if there is a dependency between another non-key attribute, then it should be eliminated. Okay. So that only. For suppose in our example, we have till now we are going through one small example in first normal form and second normal form. Now we are in third normal form. We are using the same tables which we obtained in the second normal form. So these tables these relations are in second normal form, but these are not in third normal form. Why? Because if you take course number is determining course name. Means what? Course name will be identified by using course number. Again, course number will be, actually it should be dependent. Course number should determine instructor number, but okay, instructor course number and instructor, it is determining. Course number should determine instructor name, but this is not. Means what? Instructor name can be determined by using the instructor number, no need of course number. Without the use of course number, you can determine or you can identify instructor name. That's nothing but by using instructor number, you can determine instructor name, no need of course number. Okay, means what? There is a dependency. So there is a dependency between primary key to non-primary key attribute. There's nothing but instructor number. From non-primary key to another non-primary key, non-key attribute, there is again one more dependency. Means what? Instructor name can be determined by using or identified by using instructor number. Without the use of course number, we can do that one. So it is called transitive dependency. That should be eliminated in third normal form. So what we have to do? So nothing is there. So you remove this non-key attribute, which is depending upon another non-key attribute. You take it off. Okay, and also the determinant, both you take out and make it as a new table or a new relation. Let us look into this. There is a transitive dependency. Instructor number has dependency with course number, and instructor name has dependency with instructor number. Likewise, we got this transitive dependency. Now what do we have to do? We have to eliminate all the dependent attributes. What are dependent attributes? This is dependent on instructor number. This is dependent on course number. These two should be eliminated from each of the tables that have transitive relationship, and create new tables with the removed dependency. So with instructor number and instructor name, you create a new relation, new table. Okay, and you have to check something in the new tables. That's nothing but as well as tables modified to make sure that each table has a determinant and no table contains inappropriate dependencies. That's nothing but when you create a new table, when you create a new relation, now there should be some determinant. What is determinant? That a key attribute should be there. Okay, based on which others will be identified. So when you observe course number, course is a newly formed table. So earlier we have student, course grade, and course instructor. Now we divided that course instructor into two different tables, course as well as instructor. So course is the new table for suppose obtained, or otherwise the table newly obtained. Now here, if you look at course number is determining course name. Course number is determining or identifying the instructor number. So course number is a determinant, course name and instructor number are dependent. Similarly, instructor number with instructor number, instructor name and instructor location, another relation is created. Here the determinant is instructor number and instructor name has dependency, instructor number and instructor location has dependency. So there is a determinant here. So we are checking that there is a determinant in the newly formed table. Okay. So now this database is in third normal form. No transitive dependency. Okay. For suppose another example, we have a table beaches. Okay, beach tables with the list of beaches and the region, country, as well as ID. Okay. So when you look for dependencies here, or suppose there is a dependency between region and country. Means what? This particular region is present in this country. Okay, there is a dependency, but actually these two region is a non-key attribute, country also non-key attribute, so there is a dependency. Means what? Definitely there will be a transitive dependency over here. Okay, for suppose ID to name, or for suppose ID to region and region to country. Okay, but if ID is a primary key, so ID to region and region to country, there is transitive dependency. So what we have to do? So all the dependents has to be eliminated from that. Okay, so what are the dependents? Region, this is the dependent, and this is also dependent. So region and country are eliminated, and those are used to form another relation with only region and country. Here the key attribute, otherwise primary key, is region, and this key is determining or identifying the country. Okay, the leftover things are placed inside the existing table. There's nothing but ID is as it is, ID, and it is the primary key, and name as it is, and region is placed. Okay, now there will be a link between this table and this table. Link. Okay, Elizabeth, which region, which country it is? So we have to look into this table and we have to get that particular thing. Okay, so point here is transitive dependency is identified and it is eliminated in the third normal form. Now these two tables are in the third normal form. Okay, now after third normal form, there is one more normal form. That's nothing but voice code normal form. This is provided by voice code. That's why their name has given over here. And what they say is there are some anomalies in third normal form. Even though you are telling it is in a third normal form, some of the anomalies may exist over there. Okay, so it is we can say like this: voice code normal form is a special case of third normal. Third normal form only a special case. So you know to eliminate the anomalies which are in third normal form, voice code normal form, okay, is used. Now what they're telling, a relation is in BCNF if and only if every determinant is a candidate key. We have seen dependent and determinant. So here Y is dependent. In the functional dependency, Y is referred as dependent and X is referred as determinant. Okay, so there is a functional dependency between X to Y, means X is one attribute, Y is another attribute. This Y is determined, otherwise this Y is depending upon this X attribute. Okay, so every in BCNF what they're telling is this determinant should be a candidate key. It should be a key attribute. It should be a key attribute only. Okay, like primary key. Now let us look into one small example. Name of the table is STMAJADV. So student major advisor table. Means what? One particular student is studying on particular subject as major, and his or her advisor is this particular professor. Okay. So there is some rules here for this database, for this example. The rules are: one student can take many majors, and when you look at one major, okay, one advisor only will be given. One major, one advisor per a student. Okay, and if you take one major, there can be more number of advisors, And when you take advisor, they will advise only one major in this example. And advisor advises several students. Means what? One advisor will teach one major to multiple students. These are the semantics to be followed here. Okay. So now the thing is, what is the candidate key here? Now, when you look for candidate key in the sense, it is used to identify one record or one row or one object uniquely in the database, in the relation. So you cannot use 111 for primary key. Otherwise, we cannot use the student ID as a key attribute because there are some repetitions. So in primary key, repetition should not be there. So it should be combination with something else. That's nothing but, for suppose, student ID with major can be used as a candidate key or primary key, or student ID combined with advisor can be used as a primary key, but not single. Okay. So this particular student under this advice. Otherwise, this particular student is taking care of this subject. So like that it is. Okay. So now, so the thing is, if you look for functional dependencies, student ID major is determining the advisor. Not only the student ID plus major will determine the advisor. Means what? 111 directly is not depending on Smith. 111 physics only Smith, because 111 music is Chan. So it is not, I mean, advisor is not depending upon only the student ID. Advisor is depending upon student ID as well as, and major is depending upon advisor. For suppose Smith teaches physics, Chan physics, music. Okay, White physics. Okay, so those are the dependencies. Now the problem here is, when you delete a student, then if you delete the student in this table, then advisor also should be deleted. For suppose when you want to insert a new advisor, then we need student data also. We cannot simply add a advisor data. We cannot simply delete a student data. Okay, so and there will be some inconsistencies in updating also. Okay, so this is the problem identified. This is the anomaly identified over here. When you are removing something, it is affecting some other thing. It should not be like that. That is what dependency. Okay, so that's why what they're telling is, you create a relation with in that relation there should be functional dependencies, and those functional dependencies, in that functional dependency, determinant should always be candidate key. Determinant should be always candidate. Means what? From the candidate key only, from the primary key only, there should be dependency with a non-primary non-key attribute, but not in another manner. Okay, so that's why it means what? Dependencies should not be there. Okay, so that's why we can divide the table into two different tables, two different relations. One is student and the advisor, another one is advisor and the major. Okay, so in student advisor, student ID and advisor both are the primary key. Okay, because we can identify a row only with these two, but not either only advisor or by only student ID. And in advisor major, advisor is the primary key and major is a non-primary key, and there is a functional dependency between advisor and major, where the determinant is the candidate key, so it is following the BC. Here, entire thing is a primary key, so it is also following BCNF. So likewise, we can obtain a relation in BCNF like this. That's nothing but make sure that all the determinants of all the functional dependencies existing in a relation should be from a primary key or a key attribute or a candidate key. Okay, so with this I'm concluding this BCNF.